So if we say this is the 6 transistor memory cell, now over here I have changed the nomenclature from Q and Q bar to blti and blfi. Okay, but it means the same thing. Don't worry about that. Okay, so what we do is, before anything happens, we keep, before the word line comes, we actually keep the bit lines precharged. Precharged means that they are, so these bit lines are essentially capacitances. So we say that these capacitances are held at or precharged to some voltage level, let us say VDD itself. Let us say they are precharged at VDD level. When word line goes high, what happens? These NMOSs will turn on. These NMOSs are called excess transistors. These NMOSs will turn on. They will allow access to the contents inside the memory. And because there is a 0 written here, the charge would start to flow like this. On this side, over here also it is 1, over here it is VDD. Both sides is VDD. Over here this was VDD and the other side was 0. So some charge will flow like this. And this bit line will discharge. What happens? One bit line discharged, the other bit line did not. And that is what will now in the IO region trigger the sense amplifier to complete the read operation. Is this clear? Are you able to see this? Any questions to the read operation?
Sir, can you explain this?
What part did you not understand, Abhishek?
Sir, bitline bar is discharging that part, and this is bitline bar and B. Yes, sir.
Okay. So when word line gets selected, do you see that? Okay, this is, so what I said was both the internal nodes are precharged to VDD. Both the bit lines are precharged to VDD. Yahan tak clear hai?
Sir. Yes, sir.
Okay. Now, when we turn the word line on, what happens? These are NMOSs. They
Yes,
will
sir.
turn on.
Yes, sir.
Now, what happens? When they turn on, there was a 0 stored on this side. So this NMOS will now start to conduct some current.
Yes, sir.
Will there be any current here? No. Both sides are VDD.
Yes, sir.
So some current will start to flow from here. Now this is a capacitor. You remove some, so when a current flows, some charge is removed from this capacitor.
Yes.
So when a charge is removed from a capacitor, what happens to its voltage?
Decreases. It reduces.
The voltage falls. So over here, because Bitline was connected to BLTI, which had 0 stored on it, my BL voltage falls. After some time, there would be sufficient differential between Bitline and Bitline bar, and I will be able to trigger the sense amplifier and complete the read operation.
Yes, sir.
Is this clear now?
Yes, sir.
So BLTI will get charged to VTD minus VT, right?
Why? See this, if there was a 0 stored here, if there was 0 stored on this side, then there was 1 stored on the other side, no?
Yes, sir.
So if there is 1 stored on this side, so what happens? This NMOS is also on.
Okay, so okay.
It will sink
Yes,
the
sir.
current.
It will sink the current. Yes, sir. Yes, sir. Okay.
In fact,
Yes.
if this NMOS is not strong enough, what will happen? You very rightly said, this BLTI will start to rise up.
Yes.
If this BLT starts to rise up, what would happen?
The discharging from BL will be slower than like.
Yeah, the charge from BL will become at a slower rate. But
Yes, sir.
still more worrisome thing is, you stored a 1 here, you stored a 0 here. Now this is no longer 0. This is almost 1.
Yes, sir.
So what happens?
Data
My data can get corrupted. My data can get corrupted. So during read cycle or when the word line is on, that is when my stability is lowest. because this BLTI is going up. If there was no flow of current, this BLTI would remain at 0. Are you able to see this? Because even if
Yes.
it had gone a little bit up, the NMOS is on, it will discharge. But when Wordline is on, then there is a current coming from here also. And therefore, my stability is slowest, is the least when the Wordline is on. That is where we will finally measure the noise margin of the memory cell. Okay. So read operation is clear. Any questions for the read operation?
So I'm able to understand the operation, but actual में read क्या होगा अभी इसमें? Read क्या हुआ? हमको क्या मिला?
The bitline went to 0. So the sense amplifier would say that bitline had stored a bitline BLTI was storing a 0. So the user may interpret it as read 0.
Okay. BLTI को हम देखते हैं, BLFI को. Okay.
No.
ठीक है.
ऐसा
Okay,
मैंने कुछ नहीं कहा.
Okay.
मैंने कहा user may interpret it as. मैंने ये नहीं कहा user will interpret it as.
Okay, sir.
It is your prerogative as a designer as to what it means. You may call it 0, you may call it 1. It depends on what you wrote. If when you had to write a 0, you stored 0 on BLTI, you would read it as 0.
Yes,
If
sir.
when you wanted to write a 0, you stored 1 on BLTI, you would read it as 1.
Yes, sir.
Okay. So read and write are coupled. You cannot look at them independently. So जो आपने लिखा उस basis पे आप उसको interpret करोगे whether it is a 0 or a 1. Is that okay?
Sir.
Yes, Vaishnav.
So, sir, previously we were seeing that our bitline and bitline bar were having an inverter in between, sir. So both, how can they have the same value at the same time exactly? I mean, during start, we were giving
that was a simplistic view for you. As I said, we are going to more and more real views. So these are two capacitors. I can charge those two capacitors at VDD now.
Okay, so there is no inverter in reality in between them, but we are just storing the value of this bitline and bitline bar with the help of a capacitor. That's
yeah.
Okay.
So in reality, if you notice, there was never an inverter directly between the bit lines. The inverter was on data pin, and that went to the right driver. Bit lines पे कोई inverter नहीं था.
Yes, sir. Yeah. Yes, sir.
Yeah, Ranjit.
Sir, I didn't understand how if the NMOS is slower, then how will the data corruption occur? I didn't understand that.
We will come to that. We'll look at stability in much more detail in a little while. Don't worry.
Okay,
there will be some homework assignment for you also to understand this. So it is not a graded assignment. So you can or may not, you may or may not do it, but there will be something that I will ask you to do. We will come to that. Anything else?
BLTI means?
Doesn't mean anything. It's just a name. BLTI. T could represent true node and I could represent internal. So true and false. I could have called it Q and Q bar. I could have called it anything. Don't worry. नाम है बस.
यहाँ पे जो इन्वर्टर का सर पुल डाउन है उसको सर ज्यादा वीकर रखना पड़ेगा या स्ट्रॉन्ग है, बिकॉज हम डिस्चार्ज करना चाह रहे हैं जो BLTI का नोड है.
Good that you are coming to these questions. I want to arrive at these questions in just a little while. We'll jointly find the answers to these questions. What do you think? How would you size this pull down transistor?
I think whatever the thing जो ये लेफ्ट वाला NMOS है वो पास करेगा करंट यहाँ पे, so that current should be that pull down NMOS ज़्यादा फास्टली उसको संक करना चाहिए, I think.
Yeah. So what we essentially want is that even if there is a lot of current coming from bitline onto the BLTI node, all that current should be immediately shifted away without significant rise in the level of BLTI. So that there is least impact on stability. So if I have to sink lots of current without significant VDS, the pull down should be strong, much stronger than the pull pass gate there. Much stronger than the access transistor there. So we will see. We will come into this sizing wala business in just a little while. Ranjit? Okay. Neeraj?
Yeah, sir, actually, I'm a little bit confused, like what we are reading. So, like, what I interpreted is that, like, we are just making on BL or BLB, like, on the basis of that we are reading. Is that correct?
So we're creating a differential between bitline and bitline bar, and that is what we will amplify in the sense amplifier.
Yes, sir. So, sir, like, if the case we take, like, BLTI is 1 and BLFI is 0, and, like, then the BLB
Yes.
will fall down, then we can say that we are reading 1.
Yes.
Okay, sir. Thank you.
Okay.
Sir.
Yes, Vaishnav?
Sir, so I don't know if I can ask this question right now or not, but sir, now my bitline has got discharged, and this difference which creates between the bitline and bitline bar, that is sent to the sense amplifier, right, sir? So, sir, for my sense amplifier to work, the sense amplifier signal should be enabled. So, I mean, there should be some other wire going from between these positions to the sense amplifier to enable that. So, saying that, okay, my so you can work on with my sense amplifier operation when my bitline is down and bitline bar is
yeah,
high.
so we had that SAN horizontal wire in the IO region, na?
Sir,
We
I
showed
mean,
that.
so is that wire coming from somewhere around here?
How can it come from every memory, sir?
Oh, yes.
We talked about the reference Bitcell and reference bit lines and reference word lines, no?
Yes, sir.
That was exactly for this purpose. So
Okay,
that we
okay,
could
okay.
generate the enable signal for the sense amplifier.
Got
We'll look
it.
at that in more detail later also. Don't worry.
Yes, sir.
So now, how does the write happen? For the write to happen, see, you already know what you want to write. Now, it is 0 over here and 1 over here. If you want to write into the memory cell, you would actually want it to go to 1 and it to go to 0. So you already know what data you want to write into the memory cell. Based on that, what you do is, even before the word line comes, you keep one bit line at 1 and you discharge the other bit line to 0. Then when the word line arrives, what happens? Over here now, this was at VDD, this was at 0. Over here, VDD 0. So on the left side, regular read operation will start to happen. But on the right side, what happens is this one starts to get discharged through the access transistor. Okay? When that discharges, what happens? As it starts to go to 0, this PMOS will turn on. So initially, when this was reading only, this was the voltage. We ensured that BLTI does not rise very much. But after a lot of discharge had happened, what happened? This PMOS turned on. So this will take this node to 1. And we would say that, I have flipped the contents of the memory cell. I have written 0 there and 1 here. Okay. Any questions on the write operation?
So the bitline is discharging.
Bitline has?
Bitline is also discharging.
So we discharge the bitline through that write driver.
Yeah.
The side where we wanted to write a 0, we discharged it through the write driver.
No, the bitline is in the read cycle.
So this one we will keep precharged. The bitline. So because we know this is a write cycle, what we could do is we could actually have a PMOS connected here, which is on during the write cycle. So this would remain at 1. This would not discharge. That we can do. We may do, we may not do. That as a designer, I have to decide if it helps me or not.
Sir,
Sir, how are we deciding where we need to write one, left side or right side?
The user gave you some data. Based on that, you decide whether BLTI needs to be 1 or a 0.
Okay, so suppose sir, here if you want to write one at VLTI side, so what I should do?
वही तो हमने कहा ना. If I want to write a 1 on BLTI, I know that BLFI needs to be written to 0. है ना? BLTI is equal to 1 means BLFI needs to be at 0. So that is what we just did. We took BLB to 0 and we wrote 0 on BLFI. When we wrote 0 on BLFI, BLTI automatically went to 1.
sir,
Not clear, sir. एक बार और please.
Okay. So if you want to write a 1 on BLTI, it essentially means that you want to write a 0 on BLFI. Yes?
Yes, sir.
So that is what we just did. If I want to write a 0 on BLFI, what did I do? I took BLB to 0. I wrote a 0 there. Once I wrote a 0 there, what happened? The PMOS turned on the BLTI side and it wrote a 1 on that side.
Okay, but sir, initially, if the stored data was at VLTI was 0, and
That was what the
VLFI
case was, na? If you look at it, what was the case? We said BLTI is 0. हमने यहीं से तो शुरू करा था. We said BLTI is 0. We discharged the bitline bar to 0 now. Therefore, we discharged BLFI to 0. Once BLFI went to 0, we said that BLTI will get charged
yes,
through
sir,
the PMOS.
this thing I understood. I am saying that sir, पहले से ही VLFI पे 1 है, but now user send that VLFI पे 1 लिखना है.
Now, if you want to write 1 on BLFI, then you will put bitline to 0 and maintain BLB at 1. Basically, what I am saying is you cannot write a 1 inside a memory cell because you are using NMOS pass gates. Can you transfer a full 1?
No.
You can only write a 0.
Yes, sir.
Are you able to see this?
sir, राइट में दो हमारा 1 और 0 साइमल्टेनियसली राइट करना स्टार्ट होगा, बट हमारा 0 पहले राइट हो जाएगा.
Yes.
और फिर वो उसको रीइंफोर्स करेगा 1 करने में.
Yes. You will always write a 0 first because you have NMOS pass gates. If you had PMOS pass gates, you would write a 1 first.
Okay.
Okay, Sachi?
Yes, sir, I want to know, like, how is this bitline bar is getting discharged? I mean, is it by using that D bar data as 1 so that it
Yes.
is
The drive drivers, yes.
okay. And so, sir, if D is 0 and D bar is 1, so what means by that data, we say that we want to write 1 or 0 here at PLT. Okay.
Yes.
Okay,
So that
sir.
we decide as designers.
Okay, sir. Okay, thank you.
Neeraj?
Yeah, sir, as much I understand, like if we have to write 0, so sir, can we say like we keep BL at 0, BLB at 1, and then we raise up the right line?
Yes, if you want to write the other data, like we just wrote 1, 1, 0 in the memory cell. Now you want to write 0, 1. So now in the
Yes,
next
sir.
cycle, you will take bitline to 0. You will maintain bitline bar at 1 and you will write 0 on the BLTI side.
Yeah, yes, sir, yes.
Okay. Ranjit?
Sir, I too had the same doubt as what Raghav said. So we start the right cycle from the discharging node, and once this node discharges, it drives the other inverter, which
Yes.
which charges the other node.
Yes.
Okay, yeah, understood, sir.
Sir, you said either of bitline or bitline bar 1 should be 0. So how are we deciding which one should be 0?
See, suppose the user wants to write a data 1. I as a designer can decide that when the user wants to write data 1, whether BL will go to 0 or BLB would go to 0. I can decide that. Okay? And then All that I need to do is that during read, I should know, okay, during write, I said for 1, BL had to go to 0. So when BL goes to 0, I'm reading a 1. So during read, you will use that information that you used, that decision that you had made during write, you will use during interpreting what is read.
Okay, means for read वाला हम information के according decide करेंगे.
रीड का इंटरप्रिटेशन राइट के बेसिस पे डिसाइड करते हैं, बिकॉज यू राइट एंड देन यू रीड.
Yes, sir.
Sachi, you have a question?
No sense.
Okay. So anything else? Any other question on the right operation? Is the right operation clear? Okay. So we are almost at the end of the class. What I will do is I will just introduce. So when we